In this mini-lecture we will discuss freshwater resources. After reading Chapter 15 and watching both videos on freshwater resources or reading the transcripts that go with these videos, you should be able to describe the distribution of freshwater on Earth and the major types of freshwater systems, discuss how we use water and alter freshwater systems, assess problems of water supply and propose solutions to address depletions of water bodies. In many places it seems that water resources are overabundant, however potable or drinkable water is quite rare and limited. The water on the Earth can be classified as either fresh water, that is water that is relatively pure and which contains few dissolved salts, or ocean water. Ocean water contains too many salts to drink or use for agriculture. Only 2.5% of all the water on Earth is freshwater, and of that only 1% is surface freshwater. The vast majority of fresh water, specifically 79%, is inaccessible to us because it is tied up in ice caps and glaciers. It's important to note that all the water on the Earth is connected in a large hydrologic web. Surface water replenishes groundwater, and the movement of water from rivers, lakes and oceans means that pollutants, sediment, organisms, trash, and dissolved substances can be transferred from one water source to another. So we see that as with many other elements of the environment, freshwater and marine environments are part of an interconnected system. Freshwater can either be surface water or groundwater. 20% of freshwater is groundwater, which is water beneath the surface of the Earth held in rock and soil pore spaces. Groundwater is held in aquifers, which are porous, sponge-like formations of rock, sand, or gravel that hold water. A common misconception is that aquifers are massive underground lakes. This is very rarely the case. The groundwater is usually held in pore spaces of soil and rock within the aquifer, meaning you couldn't go swim in most aquifers, even if you could physically get to it. The upper layer of an aquifer is called the zone of aeration and is the area where pore spaces are partially filled by water. The layer below that is the zone of saturation and is where the pore spaces are completely filled with water. The boundary between these two zones is called the water table. Aquifers are recharged when surface water runs over a recharge zone, which is the above-ground land area that allows surface water to infiltrate into the aquifer below. The world's largest known aquifer is the Ogallala Aquifer, found in the Great Plains of the U.S. This aquifer has supplied farmers and ranchers with water for generations. However, unsustainable withdrawals are threatening this aquifer, and many other aquifers. Groundwater can be easily depleted and aquifers recharge slowly. There are several consequences to overdrawing an aquifer. 1. Water tables drop, making it harder to extract water from the aquifer. 2. Wetlands dry up. 3. Water becomes rarer and more expensive. 4. If the aquifer is in a coastal region, salt water will intrude into the freshwater aquifer. 5. Land will subside or sink, and 6. Soil will become compacted, lose porosity, ultimately making recharge harder. Recall from Chapter 5 when we discussed the Chesapeake Bay that a watershed is an area of land where all the water that is in it, or falls within it, drains off into a singular outlet. In other words, a watershed is the area of land drained by a river system. A river system is a river and all of its tributaries. Tributaries are smaller rivers or streams that flow into the main river. Watersheds can also be called drainage basins. Remember that everyone lives in a watershed. If you'd like to find out what watershed you live in, you can follow the link I've provided in the Week 9 videos and presentations folder. We will now consider the major types of freshwater systems. The first of these systems we will consider is a floodplain. A floodplain is defined as the land alongside a river. Floodplains are at the bottom of valleys and are surrounded by uplands, or lands with higher elevation. When the river floods, it deposits silt, gravel, and clay onto the floodplain. This action makes the soil of floodplains very fertile. Consequently, floodplains are commonly used for agriculture. Another major type of freshwater system is a riparian area. This is the land along the banks of a river or stream. Riparian areas are the transitional areas between the aquatic system of the river and the terrestrial ecosystem on land. Riparian areas consist of the vegetation that grows along the banks of the river. As with most transitional zones, or the zones between two distinct ecosystems, riparian ecosystems are known for being productive and species-rich. Lakes and ponds are obviously another type of freshwater system. Lakes and ponds are standing water with distinct zones. The nutrient-rich edges of the water body, where the water is shallow enough to allow aquatic plants to grow, is called the littoral zone. This region has a rich diversity of organisms including aquatic invertebrates such as insects, snails and crawfish, as well as vertebrates such as birds, fish, turtles and amphibians. The limnatic zone is the open portion of the lake that is shallow enough to allow sunlight to penetrate its entire depth. The sunlight enables photosynthesis to occur in this zone, which means this area is teeming with photosynthetic phytoplankton such as algae, protist, and cyanobacteria. Beneath the limnatic zone is the profundal zone. This region of the lake is the open water of the lake that is too deep to allow light to reach it. For this reason, the profundal zone does not have photosynthetic organisms and thus the dissolved oxygen levels are lower in this zone compared to the limnatic zone. The benthic zone of a lake is the portion that extends along the very bottom, from the shore to the deepest point. Invertebrates that live in this zone are called benthic invertebrates and are often studied to assess the health of the aquatic system. Ponds and lakes evolve over time as they receive sediment and nutrient inputs. Oligotrophic lakes and ponds have low nutrient content and high oxygen conditions. These lakes look clear and are support a variety of organisms. Oligotrophic lakes can transform into eutrophic lakes, which are lakes with high nutrient and low oxygen conditions. The process of eutrophication is natural. For many lakes, as they age over centuries, there is a buildup of nutrients, sediment, and plant material, which slowly fill the lake basin. Eventually, the process ends and the basin becomes colonized by terrestrial vegetation. The timing of natural eutrophication is highly variable and depends on the characteristics of the basin, watershed, and climate. However, humans, by altering nutrient inputs, have greatly increased the pace at which eutrophication can occur. The final type of freshwater system we will examine a wetland. Wetlands are areas where the soil is saturated with shallow, standing water. Wetlands have an abundance of vegetation and are considered to be very diverse and productive ecosystems. Wetlands provide valuable habitat to aquatic and terrestrial organisms, such as migratory birds. Wetlands provide valuable ecosystem services such as slowing runoff, reducing flooding, recharging aquifers, and filtering pollutants. Historically, people have drained wetlands, mostly for agriculture. For perspective, the southern U.S. and Canada have lost over half of their wetlands since European colonization. One of the main reasons Hurricane Katrina was so devastating was because Louisiana drained and developed the majority of its coastal wetlands. These wetlands act as a buffer to storms, tempering the storm surges that hit the coastal states. However, when the coastal wetlands are removed, the storm surge can reach much further inland and cause significantly more damage than if the wetlands had been in place. There are a variety of types of wetlands. Freshwater marshes are usually at mouths of rivers and have shallow water and vegetation that grows above the surface of the water, such as cattails and bulrushes. Large stretches of freshwater marshes span much of the Florida Everglades. Swamps are wetlands in forested areas, such as the swamps of Louisiana. Bogs are ponds covered in thick floating mats of vegetation and may be a transitional stage of aquatic succession. Finally, vernal pools are seasonal wetlands that exist only during the wet portions of the year. As an environmental scientist, if your job is to evaluate wetlands, you must be aware of land that can serve as a wetland, even if it is only during a portion of the year. You can learn more about wetlands by taking Rangeland Ecology and Management 440. In this class, you'll learn how to delineate, or assess the size and extent of a wetland, and you'll learn how to make jurisdictional determinations related to wetlands. This is a highly marketable and useful class if you plan on going into environmental consulting. Like everything else in the environment, humans are altering and affecting waterways. To begin, we are withdrawing water at unsustainable rates, depleting surface and groundwater. Water is a limited, but renewable resource, so long as we use it sustainably. To put this in perspective, 1/3 of the world's people are affected by water shortages. This map was developed by the World Resource Institute and shows where we are overdrawing our aquifers and causing high levels of groundwater stress. Another way we affect waterways is through engineering. We build dams, levees, and diversion canals for supplies, transportation, and flood control. What we often forget is that what we do in one part of the aquatic system affects other parts. Another challenge with water is unevenly distributed in space and time. Different geographic areas possess different amounts of water and people are not distributed according to freshwater. This map illustrates available freshwater in cubic meters per capita per year. Notice that the northern portion of Africa is tan and yellow, indicating low freshwater availability. The struggles of having enough water is nothing new. Humans have always struggled to transport water from its source to where people need it. However, as our population grows, this age-old problem is evolving into a crisis in some regions. Additionally, climate change will worsen water conditions globally because precipitation patterns will change, glaciers will melt and there will be more intense flooding and droughts, among other things. Water use can be characterized as either consumptive or non-consumptive use. Consumptive use is an activity that removes water from an aquifer or surface water body and is not returned. For example, water used for irrigation. Non-consumptive use is an activity that either does not remove water or only temporarily removes water, such as is done with electricity generation at hydroelectric dams. The vast majority of fresh water is used for agriculture. This includes crop irrigation and watering of livestock. 20% of fresh water is used by industry and 10% of fresh water is used for residential purposes. We talked about the various irrigation methods in Chapter 9, so I will not review that again here. Just recall that the vast majority of irrigation systems in use today are highly inefficient because they rely on either flood and furrow irrigation or conventional irrigation, both of which lost a majority of water applied to evaporation. When we withdraw water faster than it can be replaced from either surface water or groundwater, this is called water mining. One way humans have altered the hydrologic system is by building dams. A dam is any obstruction placed in a river or stream to block the flow of water. Dams are built to prevent floods, provide drinking water through the creation of reservoirs, allow irrigation, and generate electricity. Reservoirs are artificial lakes. 45,000 large dams have been erected in more than 140 nations. At this point in human history, and especially in the U.S., only a few major rivers remain undammed. The largest in the world is China's Three Gorges Dam. This dam is created a 385-mile-long reservoir, which is the length of Lake Superior. Some of the benefits of lakes are that they provide flood control, renewable and low-carbon emission electricity, recreation on the reservoir, and reliable drinking and irrigation water. Some of the costs are that they displace millions of people, prevent nourishing sediment from traveling downstream, alter the habitat downstream and upstream of the dam, reduce or eliminate recreational opportunities downstream of the dam, harm fisheries downstream through thermal pollution and blocking migration routes, disrupt natural flooding that enriches floodplain ecosystems, and there is the risk of catastrophic collapse of the dam. There is now a push to dismantle some dams and let rivers flow free. This would restore ecosystems, re-establish economically valuable fisheries, and revive river recreation such as fishing and rafting. Old dams or those that are no longer economically viable to operate are candidates for removal. In the U.S. alone 400 dams have been removed since 2004 and 500 more may be removed in the coming decade. So what are we to do about this water shortage? Well, we can either increase supply or decrease demand. Dams were a common solution to increasing supply in the past, however, as we have discussed, there are significant downsides to dams. Desalination, or the removal of salt from seawater, is another option for creating more supply. The problem with desalination though is that it is an energy-intensive process and requires a great deal of fossil fuels and electricity. Currently we lack abundant, clean energy sources to make widespread use of desalination economically viable and environmentally sustainable. Some countries in the Middle East do have large desalination plants, but they still require a lot of fossil fuels to operate. We can reduce demand for freshwater by making wiser choices of how we use water. For example, agriculture can use drip irrigation instead of flood and furrow or conventional irrigation. Other examples featured here are a rain barrel that captures rain and stores it for residential outdoor irrigation, a shower shutoff valve that you can twist while in the shower so that you can soap up without wasting water, xeriscaping, which is landscaping and gardening that reduces or eliminates the need for irrigation. This landscaping method is used in the southern U.S. and incorporates drought-tolerant and native species that require little to no supplemental water. Being smart about irrigation and not using sprinklers in the rain or not over-irrigation such that the water just flows off of the soil and plants and onto the concrete and into the street. And finally, by using reclaimed water when possible. Reclaimed water is water that is treated but not to the point that it is potable. This type of water can be used to irrigate lawns, parks and golf courses and can be used to flush toilets. That concludes the first mini lecture on freshwater. If you haven't already done so, please watch part 2. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline.